The following is presented by the Computer History Archives Project.
Electronic servants. A rare behind-the-scenes look at the high-precision manufacturing operations of Sperry Univac in Roseville, Minnesota. This film highlights the skilled workers, engineering labs, clean rooms, assembly areas, and quality control testing at the height of operations in the late 1960s. The film shows close-up views of the specialized manufacturing of the massive Univac 1108 mainframe, the Univac 494, and related systems, produced for NASA and many other business and government entities around the world. This partially restored film is presented in its original color. Runtime is 18 minutes, followed by a detailed photo gallery from the same period. This is the electronic monster, the electric brain, the machine that is going to take over the life of man, the machine that will put everyone out of work, the electronic monster that will take over the universe. Electronic monsters of industry. This is what many people actually believed when the computer age dawned in 1947. Today, of course, we know that computers are not electric brains, but are marvelous machines that have become servants of mankind and touch the lives of us all. Computers are used in traffic control. They are extensively used by the airlines in nearly every phase of their operation. The checks you write are processed by a computer at your bank. The department store statement you receive was produced by a computer. Your magazines have been addressed by a computer. Many of the products we use every day are packaged, bottled, or produced automatically by machines which are directed by a computer. Were it not for electronic data processing equipment, modern industry would be hard-pressed to meet the production deadlines of today. Commerce might be engulfed by its own paperwork. Scientific progress would be seriously impeded. And space exploration would be impossible. Far from making jobs performed by human hands and minds obsolete, computers have created more than 1 million new, exciting, and well-paying jobs within industry, education, and government, with an estimated 300,000 to 400,000 new computer-related positions opened each year. Additional hundreds of thousands of Americans, including several thousand men and women at Univac's Twin City Data Processing Division, are engaged in the fascinating business of designing, developing, manufacturing, and testing ever faster and more efficient computer systems to fill the rapidly growing demands for these electronic servants. These demands are being met through the teamwork of Univac engineering and manufacturing, who are responsible for the development of all of the data processing division's medium and large-scale systems. Systems that are designed to process data at speeds not measured in seconds, but in nanoseconds. A nanosecond is a billionth of a second. The Univac 1108 computer's memory is composed of minute magnetic cores, so tiny that each of these jars contains 1 million of the donut-shaped iron ferrite cores. A vibrating machine jogs the cores into an upright position and organizes them into a grid pattern. "96 of these tiny squares make up one magnetic core memory plane. Each square contains 4,096 magnetic cores that, when wired, can store 4,096 bits of information. Each of the minute cores is strung with 3 copper wires, horizontally, vertically, and diagonally. It will take 8 of these finished panels to complete each core memory unit of a Univac 1108 computer. However, the memory is only one section of an 1108 computer. A computer is an electronic device requiring a great deal of sophisticated wiring and circuitry, including components such as diodes, resistors, capacitors, transistors, and integrated circuits. The coil-wound assembly area produces other components, such as transformers, reactors, and various delay line coils. In modern electronics, printed circuits have done away with much of the time-consuming hand soldering of wiring and electronic components. As a printed circuit card moves down this assembly line, the assemblers insert the necessary components. Assembly of these small, intricate components requires extremely skilled hands and intense concentration. After assembly, each card goes through the automatic soldering machine. Hundreds of these printed circuit cards make up the logic section of a computer. Despite the large number of printed circuit boards used in a Univac 1108 computer, many miles of complicated wiring are also required. The automatic wire wrap machines receive their instructions from punched cards that have been prepared by a Univac computer. These wire wrap machines work 24 hours daily, 7 days a week, cutting wire into proper lengths, routing the wires precisely, stripping insulation from the wire ends, and wrapping them tightly around the proper pins. But not even a computerized machine can perform all of the intricate wiring that goes into Univac computers. Many human hands take over the exacting work required in the subassembly areas. In the final assembly area, the many sub-assemblies are installed as the computers take shape. This is where the many hours of engineering and design starts to pay off. The reliability of every component contributes to the total as the sub-assemblies are carefully integrated into the final product. As the pioneer and a recognized leader in the research, development, design, and manufacture of high-speed electronic data processing systems, Univac is proud of the high reputation for reliability that its computers enjoy. But reliability does not just happen. It must be earned. Each of the tens of thousands of components that go into Univac computers is rigidly and repeatedly tested prior to, throughout, and following assembly. This device, for example, tests diodes before they are used. The automatic component tester inspects transistors and other components. Core memory units not only are inspected visually and microscopically during assembly, they later undergo a series of sophisticated circuitry tests by devices that scan them electronically, both for wiring errors and defective cores. The printed circuit cards are examined visually by a trained inspector. Later, they are examined by the automatic circuit assembly tester, which has a memory like a computer that includes detailed and precise instructions for testing each printed circuit assembly. The automatic wire wrap machine has been computer programmed for precise accuracy. Nevertheless, its output too must undergo stringent testing by another computerized device, the wire analyzer system. This is a lineup of Univac 1108 computers and operator consoles that are undergoing a series of exhaustive test procedures lasting for several weeks. They are subjected to programs that simulate the uses they will be put to by the customers who have purchased them. This kind of thorough testing has paid off for Univac by making its name synonymous with reliability. However, a computer cannot operate without what we call peripheral or input and output equipment. Information can be put into and taken out of a computer by means of various types of equipment: magnetic tape, high-speed printers, punched cards, and magnetic storage drums. This visual display unit, called a uniscope, is both an input and an output device. The question gets asked, how does a computer think? The answer is that it doesn't think. It doesn't do anything unless it's told to by a human. Simply stated, A computer responds to an electrical pulse, or the lack of one. Think of the electrical pulse as a 1, no pulse as 0. 1 and 0. That's computer language. By combining those two symbols in an endless number of combinations, you have a code into which almost any body of information can be broken down. This is a highly oversimplified explanation, but essentially that is how a computer operates. A computer stores data. It can compare data, and it can do arithmetic, but only exactly as its human programmer instructs it. Without the programmer, who is an expert at computer language, the computer is nothing but an expensive mass of electronic hardware. While computers produce data in milliseconds, microseconds, and nanoseconds, programmers work a little slower. Setting up a computer system, supplying it with all the necessary data and instructions can take months. For example, larger systems may take 50 programmers an entire year to program. The Univac 1108 has a core memory storage capacity equivalent to 36 newspaper pages, and it can transmit every last word of that data in 1/3 of a second. For customers requiring vastly more storage capacity, there are Univac magnetic storage drums that are also produced at the Twin Cities Data Processing Division, and they can be integrated into the 1108 as well as other Univac computer systems. Univac pioneered the development of magnetic drum computer memories. The drum is a cylinder with a magnetized outer surface on which data is recorded. The FH880 magnetic storage drum can store 30 million bits of information, and it can read and write that mass of data in 15 seconds. Univac's Twin Cities Data Processing Division also produces other computers. The 494 operates at a speed of 375 billionths of a second. One of the 494's many applications is in the controlling of manned space flights. The Univac 418 medium-scale computer can store the equivalent of 9 newspaper pages and transmit the data in 1/5 of a second. Far from resting on its hard-won laurels as a computer industry leader, Univac, at its suburban Twin City operations, constantly searches new horizons of computer efficiency. Here at the Data Processing Division Test Computer Facility, computer systems currently under production are tested and evaluated around the clock in the never-ending quest for still higher plateaus of excellence. This search for excellence has produced the Uniscope, which utilizes the cathode ray tube that enables the unit to function both as an input and output device, and to display both types of data on a viewing screen. To meet the computer industry's expanding role in many fields, Univac is constantly producing more compact, faster operating, and more efficient electronic data processing systems. There aren't any electronic brains at Univac, but there are thousands of people engaged in the fascinating challenge of building electronic servants that enable man to explore horizons of creative thinking not dreamed of a decade ago. There are no boring or dull routine jobs at Univac. The reliability and efficiency of the fantastically intricate data processing systems depends on the highly creative minds and the alert and exacting workmanship of every person. As data processing equipment and components become smaller and smaller, the computer field grows larger and larger, with a need for more people. People with a look to the future and a pride in their work. People like those at Univac, who are proud to build the electronic servants that magnify man's mind.